And so today we have two great presenters, Lisa Beers and Kelly Ignayan from SFEI. And Lisa will begin by presenting the new tidal wetland acreage numbers for the Bay and showing how the WRMP is able to track the region's progress towards meeting its tidal wetlands goal and showing the benefits and impacts of the Measure AA funding to the region. And then Kelly will describe the protocol that has been developed to calculate these acreages and explain the data sets and the tools that went into the analysis. And having a standardized and a repeatable protocol is just so critical. It's that first step to being able to track change and the region's progress over time. So during the presentations, please add any of your questions and your comments in the chat. We will all be monitoring that. As well, we will have time at the end of the presentations for any questions or discussion. And before we start, we did just want to take a moment, if you go to the next slide, please, Lisa, to acknowledge why this work is so important, how wonderful our marshes are, and the numerous benefits that they provide to the region. So they include carbon sequestration, flood protection, protecting shoreline communities and infrastructure, providing habitat for native endangered species, and supporting cultural and recreational uses. And thanks to Aviva and Lisa for taking these beautiful photos while they were out in the field. And now I would like to introduce our first speaker, Lisa Beers, who is one of the co-lead scientists of the WRMP, along with who's also on the call. Lisa?
Great. Thank you, Christina, for such a great introduction. And thank you all for joining us at the last minute on Google Meet instead of Zoom with its outage. I wanted to start off by acknowledging the program that all of this work has been conducted under. It's the Wetlands Regional Monitoring Program, and the WRMP, shorthand, delivers coordinated regional monitoring of the San Francisco Bay's wetlands. And our main goals are to inform science-based decision-making for wetland restoration and adaptive management, and increase the cost effectiveness of permit-driven monitoring associated with the wetland restoration projects. The WRMP is co-managed by the San Francisco Estuary Partnership and San Francisco Estuary Institute, and we are funded in part by the San Francisco Bay Restoration Authority and the EPA. Currently, we are collecting monitoring data on vegetation, accretion, fish and fish habitats, water quality, and much more. And I encourage you to visit our website to get more information on the WRMP. So I wanted to start off with a high-level overview of the importance of tracking tidal wetland extent. Like Christina mentioned, tidal wetlands provide numerous benefits to San Francisco Bay, including carbon sequestration, flood protection, habitat for native and endangered species, shoreline protection, improving water quality, supporting a range of cultural and recreational uses. And over 75% of the Bay's tidal wetlands have been lost since the 1850s. And it's our collective investment in conservation and restoration since the 1990s that's reversed this trend of loss. The last Bay-wide mapping effort occurred 15 years ago, and it's important to understand how and where these important ecosystems are changing over time. And it is actively changing as a result of the large investment in restoration that has occurred over the past 30, 40 years, and a lot with environmental variability, such as sediment availability. So these ecosystems are definitely not stagnant over time, and it's important to regularly and consistently map them. So as part of the WRMP, we've developed a tidal wetland extent protocol. And some of the reasons why we've been, that we established this protocol was that people regularly have questions about how much tidal marsh acreage is within the baylands. And like I've mentioned previously, the last baylands mapping effort occurred in 2009. So we created this protocol to ensure that the mapping and tracking of tidal wetland extent and restoration progress. We employ a new tidal wetland classification for restoring sites that are not yet vegetated. And our aim is to add transparency to the 2020 acreage with the way we are bringing together the baylands habitat map and project tracker restoration together. And I will go into more details about all of these momentarily. So starting first with the baylands habitat map, or we call it BHM 2020. So it does reflect our conditions in the bay as of 2020, the first mapping effort since 2009. It was created by the WRMP using automated, consistent, and repeatable methods. It uses object-based image analysis, and it's a way of taking raster data or pixels and grouping like pixels together into objects, which makes it easier for analysis. It uses high-resolution aerial imagery, and we use the NAPE imagery. We use LiDAR elevation data in order to capture what the elevations are across the estuary, and this is a combination of multiple sources for BHM 2020. And we use other metrics, all of these combined to classify the habitats within the areas that were formerly or currently tidal, I should say. So we employ a standardized habitat classification scheme, and you can see on the left that there are 18 classes that we use to classify habitats. And the goal is to update this map every 4 to 5 years. We are in the process of collecting data for the 2025 baylands habitat map. So that will be released later next year. And one key thing to point is that these methods can be applied outside of the Bay Area, and it could be useful for consistent mapping across the entire state of California or larger extents. So the second main level of data that we use within our protocol is the project tracker tidal wetland restoration map of 2020. And it's derived from the Eco Atlas Project Tracker web tool, and it is a map of tidal wetland restoration sites that were intentionally and unintentionally restored through 2020. And I'll get into this briefly a little bit later. We did modify this analysis to only include sites that were restored before January 1st, 2020 to match the conditions that were monitored or captured within BHM 2020 input data. So say if a wetland site was restored in December of 2020, that wouldn't be appropriately classified with imagery that was collected in, say, June. And you will learn more about this project tracker tidal wetland restoration map from Kelly, who will be presenting right after me. So how does this protocol work? So we take the baylands habitat map, which is classified, and in this example, we're using all areas that could potentially be tidal wetlands or are currently tidal wetlands. We add in the project tracker tidal wetland restoration map, which has the boundaries of our restoration sites. And then together, we are able to get the tidal wetland extent and restoration progress. Diving into this a little bit further, it is really important to be able to accurately track tidal wetland extent and restoration development over time and across regions, especially in light of Measure AA, which is supporting tidal wetland restoration writ large across the Bay. And one thing that's important about our new classification scheme is that it acknowledges site differences. So it's well known that a fully vegetated site has different ecosystem functions than one that is mostly a tidal flat. Or so that's a site that's still gaining elevation so that it could be vegetated. Depending on the location of where a wetland is, sediment availability can vary, and this can influence the rate of reaching vegetated elevations. And in the future, Increases in the frequency of flooding and changes in sediment supply in the future may impact restoration trajectories and the speed at which they are reaching a vegetated state. So there are multiple ways that you can look at a map of tidal wetland extent. From a larger view, some people might just be interested in where tidal wetlands are writ large. And so in this case, we're looking at an image or a classified image of wetlands along the Napa River. But in a lot of cases, we want added detail so you can see where restoration sites are compared to sites that are mature. And then diving down even further within our protocol, we're curious about what's happening within these restoration sites, if they're reaching the elevation to where you have vegetation, or if they're still actively accreting. So getting into what our redefined tidal wetland habitat classifications are. So in dark green, we have our existing tidal wetland. And this is ancient or centennial tidal wetland that occurs outside of restoration projects. So by ancient, I'm meaning sites that have been around for 5,000 to 6,000 years. And the centennial sites were those that were created through placer mining in the 18 and 1900s, which brought in a lot of sediment from the Sierra Nevada mountain range. Our next classification is the restored tidal wetland. And these tidal wetland areas have been restored to tidal flow and now support wetland vegetation and well-defined channels. You may still find areas that include undifferentiated open water in tidal flat, however. And then our third category, which is a new one that we were employing, is the evolving tidal wetland. And these are tidal wetland areas that have resulted from recent or ongoing restoration activities, but have not yet developed wetland vegetation and well-defined channels, and they're often lower in elevation. So to give you a few examples of what's included and what's not included within each of these classifications. So these 6 classes are commonly referred to as the complete marsh, where we have a shallow subtidal areas that are often outside of a wetland, tidal flats, low marsh, high marsh, intertidal channels, and tidal ponds and pans. And for our existing tidal wetland classification, we're focusing on the 4 lower classes of the vegetated marsh, the intertidal channels, and the tidal ponds and pans. We are not including for our acreage shallow subtidal and tidal flats, but I fully acknowledge that they are very important parts of our ecosystems, but we're just not including those within the acreage of existing tidal wetlands. So here's a case of 2 tidal existing wetlands. San Francisco Bay, we have China Camp State Park along San Pablo Bay, and Petaluma River Marsh along the Petaluma River. And this is what they're classified as using the Baylands Habitat 2020. And then applying our protocol, you can see that the majority of these sites are being classified as existing tidal wetland. Along the western portion of Petaluma River Marsh, you can see where there has been some restoration activity, but writ large, these sites are being consistently classified as existing tidal wetlands. Moving now into our restored and evolving tidal wetland classifications. So this is when we bring in the Project Tracker Tidal Wetland Restoration Map. So this is providing the boundary within which we're making these more detailed classifications of our restoration sites. So what we're calling restored tidal wetland includes the same classes as an existing tidal wetland. So these sites have matured to the point where they're basically functioning like an existing wetland. And then we also want to draw attention to the area within these restoration sites that are not quite at that place yet. So this is including the shallow subtidal and tidal flats. So some examples of a restored tidal wetland, we have Pond A21 in the lower South Bay and Outer Bear Island in the South Bay. And these are older restoration sites that are largely vegetated. So we include our Project Tracker layer, and then our protocol to be reclassified into our restored tidal wetlands. And as you can see, the majority of these sites are classified as such, and there is still some area of evolving tidal wetland. Next, we have our evolving tidal wetland classification. And so these are younger restored sites, or in some cases, they're older as well. So we have the Sonoma Baylands and Sears Point along San Pablo Bay, and Pond A19 within the lower South Bay. We apply our project tracker restoration map to get the boundaries within which we are applying our protocol. So you can see that the majority of these sites are still within the evolving tidal wetland class, although they are starting to have vegetated areas within which, and I think it's really important to have this differentiation within restoring classes, because we're able to see how these sites are evolving over time, or if they're actually stalling and not really evolving. And this is important to track in our restoration goals and successes. So taken all together, we're able to pull this together for the 2020 tidal wetland extent using our protocol. So maybe curious what the values are for our 2020 tidal wetland extent. And we have 53,700 acres of tidal wetlands. So how has this changed over time? So back in 1998, with the Baylands Ecosystem Goals Report, there was a target of establishing 100,000 acres of tidal wetlands within the Bay. There have been some mapping efforts over time, first with the Eco Atlas map in '98 and with BARI in 2009. And so we can see that we are increasing our tidal wetland area writ large over time. I will point out that both of these values that are listed here are from the 2015 Baylands Ecosystem Habitat Goals Report. So now applying our new protocol, in addition to the restoration areas that were used within the BayGOO report, we can see that there has been an increase in restoration over time, and that we're approximately halfway to our goal of reaching 100,000 acres of tidal wetlands. And one thing I will note within here, so the color classes are the same from what I previously showed with our restored tidal wetlands and evolving tidal wetlands. And you may see that there is this decrease in what's being classified as an existing tidal wetland. And this apparent loss of this is an artifact of our new protocol classifications, and also inclusion of more unintentionally breached restoration sites. So historically, those would have been classified as an existing tidal wetland, but within our new project tracker protocol, we're drilling down and being able to highlight which sites were restored and which sites were actually naturally occurring. So just to show some maps of where we are at with our tidal wetland extent. So circa the 1950s, the majority of the bay was surrounded by tidal wetlands. In 1998 was the first effort to quantify how many tidal wetlands we had left and capture where some of the restoration sites are. And these classifications are what was reported within the Baylands Ecosystem Goals Habitat Update from 2015. Moving forward to the BARI layer developed in 2009, you can see that there's more tidal wetlands that have been restored. And then now looking at our new classification using our Baylands Habitat Map 2020 and our new protocol, we're just getting a higher level of detail of how many of our restoration sites are vegetated and how many of those are still increasing in elevation. One thing that is really exciting about this new project tracker layer is that we're able to see or to classify when a site was restored and how this is changing over time. And just to orient you on this graphic, on the two different X or Y axes, on the left, we have our restoration acreage, and on the right, we have our total wetland acreage. So you can see we have approximately over 20,000 acres of restored marshes, and taken together with our existing marshes, we're at 53,780 acres as of 2020. And I just wanted to draw your attention to specific points in time that have been important for acknowledging the the importance of tidal wetlands within the Bay Area. So in 1998, that was when the Habitat Goals Report came out, and we set that ambitious goal of having 100,000 acres of tidal wetlands. In 2006 was the very beginning of the salt pond restorations, both within the South Bay and the Napa-Sonoma region. And you can see that there is a sudden increase in the amount of restoration area with the implementation of these restoration projects. And also I wanted to highlight in 2016 how we have, when the Measure AA passed, and that you're starting to see an increase in restorations as a result of this funding coming in. I wanted to dive a little bit further into what we've been classifying or have been talking about as intentional versus unintentional tidal wetland restoration. So it can occur from both avenues. With an intentional restoration, like you see in this photo here from the restoration of Pond A21 in the lower South Bay, it occurs through a coordinated effort and often entails site work to prepare for the return of tidal flows. Unintentional breaches can occur from levee failures, floods, and tide gate failures, among others, and often don't get repaired due to the high costs. Since the outcome is still the same, you are getting restoration of tidal flows, both should be tracked, and that provides a unique opportunity to examine restoration outcomes. And this is an example of an unintentional tidal wetland restoration that occurred in the Delta, and you can see where the levee had broken. So we can overlay this information of how many of our restoration sites were unintentionally breached. And I wanted to point out that unintentional breaches accounted for all of the restorations prior to 1966. And the Faber-Track Marsh was the first intentional restoration within the Bay. Also wanted to highlight that the passage of the Clean Water Act in 1997 helped to accelerate tidal wetland protection and restoration. And you can see how shortly after that, there was a large increase in restoration efforts within the Bay. So there are a few caveats to our tidal wetland extent acreage that I've reported. First off, I wanted to point out that we are not including muted tidal wetlands and managed wetland acreage within our totals. Also wanted to note that we had defined the boundary for the Baylands habitat map using operational landscape units, which I don't have the time to go into detail currently, but at the eastern edge of these operational landscape units are two tidal wetland sites, Brown and Winters Island, and they're not captured within the map, so we're not capturing them within the acreage. So with our next iteration of the Baylands habitat map this year, we will be able to modify the extent that's more aligned with the Regional Water Board district boundary, so that we are capturing what's traditionally included within the lower estuary areas. We're also not including acreage of in-progress restoration sites. So that's where construction has begun, but it's not tidal. But in future versions of the Project Tracker Restoration map, these areas will be included so people could have a sense of what might be expected in tidal areas in the future. And for those people who want to get into the nitty-gritty technical details, we do have a lot of information in our report appendix. So that's a step-by-step approach for calculating the 2020 tidal wetland extent, comparing how the classification is different between the Baylands habitat map and BARI, which was the last mapping effort in 2009, and also just differences in the mapping methods as well. There's a section on accounting for restoration and tidal wetland estimates, and then also a section comparing current and previous tidal wetland extent estimates and why we are seeing different areas over time and where the sources came from. And I just wanted to conclude in my section about highlighting the importance of mapping and continued monitoring within the Bay. So I just want to highlight that there are expected changes in these important ecosystems, and there is the need for regular and consistent mapping. So along northern San Pablo Bay and Strip Marsh East, there has been some expansion of the pans and erosion along the bayland edge. And so with a repeated tracking over time, we can see how this is changing here and within other sites. We can also track the massive restoration progress that's happening throughout the bay. And I'm just pulling one example out with a large-scale restoration in the Sonoma Creek Baylands. And this can also inform adaptive management of restoration by doing repeated mapping and consistent mapping. And additionally, there is natural wetland creation happening, an example of which is in Calaveras Point in the southern bay, where historically the areas that are in yellow, there wasn't a tidal wetland, but because of sediment availability or more sediment, this marsh is prograding. And with that, I'd like to acknowledge my co-authors. I'd like to acknowledge the Wetlands Regional Monitoring Program's Technical Advisory Committee for providing a very thoughtful review. And you can find the report here. And with that, I will pass it off to Kelly.
Thank you, Lisa. Great. Good afternoon, everyone. I'm Kelly Ignan, and today I'll be introducing the Project Tracker Tidal Wetland Restoration Map. This is a new data set that offers a powerful way to track wetland restoration efforts across the San Francisco Bay region. As you can see, we're bringing together two powerful tools today, the Baylands Habitat Map 2020, which Lisa just presented on, and that gives us a comprehensive view of our wetland habitats. The Project Tracker Tidal Wetland Restoration Map allows us to specifically focus on restoration sites, and together they give us a complete picture of our restoration landscape. So let me tell you exactly what's in the Project Tracker Tidal Wetland Restoration Map. It's a carefully curated data set of tidal wetland restoration efforts throughout the San Francisco Bay region. We've created this from entries in Project Tracker with two distinct versions being released. First, the 2020 version captures all projects completed by the end of 2020, and this version was specifically created to support the WRMP 2020 Tidal Wetland Extent Report Update, which Lisa just presented on. We've also released a 2024 version, which includes all projects completed or in progress by the end of 2024, giving us our most up-to-date view of restoration activities. Okay, so we know the Project Tracker Tidal Wetland Restoration Map, or PTTWRM, is quite a mouthful. So we lovingly in-house refer to this data set as the pitworm, but don't worry, the data is not nearly as intimidating as the acronym. But I just will note that I will be referring to the data set as pitworm throughout the presentation. So why is the pitworm so important? You might be wondering why we've invested so much effort into creating this resource. So the pitworm can help us answer key questions like where are wetlands being restored and how much wetland is being restored. This information is essential for regional planning, tracking progress, and informing policy. What makes the pitworm especially valuable is the consistency it brings to how we count and categorize restoration. In the past, different agencies and organizations have relied on different versions of this data, but now with the PTTWRM, we can have a really unified approach. If you remember, the PT in pitworm stands for Project Tracker. For those of you who are familiar with SFEI's Eco Atlas, I wanted to clarify how they're connected. Eco Atlas is our statewide platform for visualizing habitat conditions and ecosystem context. Project Tracker lives within EcoAtlas and captures who's doing what restoration work, where, and why. For those of you who might not be familiar, let me explain what Project Tracker is. Its purpose is to track aquatic habitat projects throughout California with a focus on restoration, mitigation, and enhancement projects. Project Tracker features detailed project information, including goals, status, locations, and partners, and supports planning, reporting, and performance tracking at the site level. Because it's fully integrated into EcoAtlas, it connects project level data with landscape level context, enabling for more informed decision and coordinated restoration across the region. So specifically, the pitworm tracks tidal wetland restoration in the bay. Currently, it includes 148 in progress and completed restoration sites that 1, restore tidal action, and 2, lead to a net increase in habitat area. Importantly, it also includes dates of restoration events, allowing us to track the timeline of restoration activities. So let's clarify what we mean by tidal restoration. And in the context of the pitworm, there are 4 distinct categories here. Intentional levee breaches, like at Cullinan Ranch, where we deliberately create openings to allow tidal flows. Unintentional levee breaches, like the one out at McCormick-Williamson Track, which happen when high water or erosion cause a levee to give way. Fill removal and tidal channel construction is our 3rd category, which involves removing soil to restore natural water flow, as seen at Dotson Family Marsh, and where we're really reshaping the landscape to allow for tidal connections. And our 4th and final category is the termination of dredging operations, shown here at Bahia Lagoon before and after 2002, excuse me, where stopping sediment removal allows for marsh to develop naturally. So it's important to note what currently isn't included in this version of the data set, but these are things we hope to include into the future. So muted wetland restorations are not included here, and these are the sites where tidal influence is limited or constrained by either by natural features or by management. Enhancement projects, which are those which are focused on more on improving the condition of existing wetlands without increasing that total wetland area through restoration. Currently, we are including projects that are in progress, meaning that groundwork has started. However, we hope to include in the future projects that are shovel ready. And those are ones where they're ready to go, but groundwork has not yet begun. In the future, we also have to expand our spatial area to include tidal wetland restorations out into the delta. We know these are important aspects of wetland work, but for now we're focusing on fully tidal wetland restorations in the bay. So I want you all to get excited. Really excited to announce that this data set is currently available for download, and you can access it at sfei.org/PTTWRM. We really encourage everybody to go and explore this valuable resource. On the site, you can access the spatial data, the associated metadata for how we produce this data set, and also an Excel spreadsheet version of the data set for those of you who prefer to not work with spatial data. So how can you use this new resource? Well, there's numerous applications, but also we are putting it out there for your application and use. We can use it to track restoration progress, including the age of breaches and restoration trajectories, even for unintentional restorations. We can use it to analyze, monitor, and troubleshoot restoration efforts, learning from both successes and challenges. And perhaps most importantly, we can show regional accomplishments and impacts, something especially important for initiatives like Measure AA, which fund shoreline restoration and flood protection projects around the San Francisco Bay Area. So here's a great example of how the pitworm can help us track wetland change over time. These images show Pond A6 in the South Bay in 2011 and 2024. So levees were breached in the pond in late 2010 and had tidal flows return. So in this early imagery, it looks like a flat, open pond. And now currently we can see tidal channels, sediment buildup, and growing vegetation, which is all evidence that of its shift towards a natural tidal wetland. So to get into the nuts and bolts a little bit of how we created this data set, we did this through a systematic review process. And creating the pitworm wasn't really a small task. We systematically reviewed over 575 project tracker records, checking and updating project attributes to standardized values. Through our process, we reviewed existing project information, consulted project plans, reached out to managers and regional experts, and we carefully examined historical aerial imagery to verify details as needed. We also updated boundaries using improved mapping from the Baylands habitat map. As you can see in this example from American Canyon, the previous boundaries in Project Tracker weren't as precise as they could be. Our updated mapping provides a much more accurate representation of the restoration areas, which you can see here on the right. So to go into a little bit why the pitworm was needed and important, it's important to kind of go back into how data gets into Project Tracker from our regional partners. So this diagram shows how project information flows from restoration managers to a regional eco-atlas administrator, who then reviews and approves the records before they appear in Project Tracker. There are several eco-atlas administrators, like the San Francisco Bay Joint Venture and the Regional Water Quality Control Board. Each plays a role in reviewing and approving the data submitted to Project Tracker. To add a little more complexity, Project Tracker also includes legacy records. So these are kind of older records that might have not gone through the current review process, but still provide valuable historical context. This is where the pitworm comes in. So it pulls from Project Tracker, but only includes records with specific tidal wetland restoration attributes. And this is where we've added a key step, which was really made possible through the funding in the WRMP, which is to do a regional review and standardization. So this really ensures that every record in the pitworm meets a consistent criteria that reflects our shared regional standards. And I just want to note that as pitworm pulls from Project Tracker, it is a static snapshot of Project Tracker at a specific moment in time. This allows us to create a versioned, reviewed, and citable data set that project managers, researchers, and policymakers can confidently use. So looking ahead, we're already planning for the future. The Baylands Habitat Map data collection for the next update begins this spring, and the pitworm will be updated annually to keep it current and useful. And I want to close with a call for feedback. We do really need this to be a shared restoration community supported effort. So your input as you use this data set is really invaluable in making this resource as useful as possible. And I'd like to give a real thank you to our restoration practitioners on the ground, the regional administrators, and the funders who make this work possible. This is a truly collaborative effort. And in case you missed it the first time around, the pitworm is now available for download, and we really encourage you to explore it and let us know what you think. If you have any questions or feedback, please don't hesitate to reach out to us. And I'd like to thank you for your attention today as we presented. I'm going to pass the microphone back to Christina Grosso to facilitate our question and answer session.
Thank you so much, Kelly and Lisa. Your presentations were so informative and really just highlight these amazing science products for the WRMP. So thank you so much for your beautiful slides and taking the time to present this information.